Okay, so in this related rates problem, we have a ladder that's resting against a vertical wall, and what's happening is the bottom of the ladder is sliding away from the wall at a certain rate, which is going to cause the top of the ladder to slide down the wall as well. And then the question is going to be, at what rate is that ladder sliding down the wall when the bottom of the ladder becomes a certain distance away from the wall. So I'm going to draw a picture here. What we have is a wall where I've got some ladder leaning up against it. And then we've got the ground down here. And essentially what's happening, so I know that this ladder is a 10-foot ladder, okay? It's a 10-foot ladder. This ladder will always be 10 feet. What's happening is this ladder is sliding away from the base of the wall, and that's going to cause it to, if it slides this way, it's going to cause the top of the ladder to slide down the wall that way. So what's going to happen is I'm going to end up with, and I'll just make this a dashed line. What's going to happen is this ladder is going to move where it's now going to be down here somewhere, where this ladder is still 10 feet because it's sliding out this way. Okay, so what's happening is as that ladder slides away from the bottom, it's sliding down the top. It's still going to be 10 feet. So that's not going to change, but these lengths are going to change. Okay, so that's the situation that's going on. Hopefully that's okay, that we can make that picture. So let's think about the information that we have and what kind of formula we could come up with to help us solve this problem. What I'm going to do first is I'm just going to label this X, I'm going to label this Y, and I'm going to label this Z. And hopefully those variables are okay. If you wanted to do it for something that makes more sense, that's fine, but I'm just going to use X, Y, and Z. This would be a right angle right here, right? Because it's a wall, and hopefully they built that wall well, and it's at a perfect right angle with the ground. What do I know? The ladder is sliding away from the wall at a rate of 1 foot per second. So if the ladder is sliding away from the wall, that means that this rate, the dx dt, is going to equal 1 foot per second. This is the rate at which it's sliding out that way at a rate of 1 foot per second. So the dx dt, the rate that x is changing with respect to time, is 1. How fast is the top of the ladder sliding down the wall? So what I'm trying to find is what is dy dt. That's what I don't know. I want to know how fast is this changing as this is changing at 1 foot per second. And I want to know, when does that happen? What is the rate when that happens when the ladder is 6 feet from the wall, when the base of the ladder is 6 feet from the wall? So when x is 6, what is that rate that's changing vertically? So hopefully you can see, if we have a right triangle and I'm concerned about the side lengths, I don't care about the angles at all. Nothing in here asks me about the angles. But if I have a right triangle and I'm concerned about the side lengths, let's go to x squared plus y squared equals z squared. Right? We can use the Pythagorean theorem on this problem. So if I do that, now I'm ready to take the derivative, and I know I mentioned in a prior video to this that you don't necessarily always want more than 2 variables. In this case it's okay because I'm going to have enough information, or I'm going to be able to find enough information to fill in for everything that I need over here. So I'll go ahead and take the derivative. Keep in mind I want to do derivative with respect to time, so I'm still going to do essentially 2x, but I'm going to chain on a dx dt. And we don't usually do that with implicit. We didn't do that with x because x was always our variable. Our variable is t, not x. So I do need to chain on that dx dt. And this is going to be the same all the way through. Plus 2y dy dt equals 2z dz dt. Okay, now some of the information, I think it's pretty clear to see what you have. I'm concerned about when the base of the ladder is 6 feet from the wall, so I'm going to use x equals 6 for that. I know the rate that I'm going to have for dx dt because that's given to me, the rate that it's changing at the bottom, which is 1. For right now, I don't have y, right? It didn't give me, when x is 6, what is y? I don't know, so I've got to figure that out. But I can figure that out. And I'm trying to solve for dy dt, so I know I don't have anything there. 2z is the length of the hypotenuse here, which is the length of the ladder, which is 10. And if we think about dz dt, that's the rate at which the ladder is changing, the rate at which this hypotenuse changes. That's going to be 0. And why is that 0? Is because the ladder doesn't change height. It's 10 feet there, it's still 10 feet whenever it slides down the wall. Right? It's always 10 feet. So the rate that it's changing, it doesn't change. What does change is this vertical and horizontal component of where that ladder is at with respect to the wall and the ground. Okay? But the ladder itself not changing in size, so that's going to be 0. So I've almost got everything I need to solve for dy dt. The one thing I don't have is what is y when x is 6. So what I'm going to do is I'm just going to kind of draw a triangle out to the side. I know that the ladder is always 10, and I'm concerned about when x is 6, what is y? And we can find that out. We know that this is a right triangle, so all I need to do is use the Pythagorean theorem that says 6 squared plus y squared equals 10 squared. And if you were to solve that, or you remember that things such as 3, 4, 5 triangles exist, you should be able to tell that this is going to be 8. When the x is 6, the y will be 8. And you can solve that for y to find that. But this is very nice. It's a 3, 4, 5 triangle. So I know because of this, I had to bring this in to find that y, that this is going to be 8 when this is 6. And now I have everything except for dy dt. And I should be able to solve for dy dt. This is going to be 12 plus 16 dy dt equals 0. All of this multiplying by 0 over here. And so to solve for dy dt, I would simply subtract 12, divide by 16. I'll reduce that. It's going to be negative 3/4. And again, unit here is, we're talking about feet, and we're just talking about a length. So this is just going to be negative 3/4 feet per second. And I want you to think about if it makes sense that that answer would be negative. If the x rate is positive, that means the bottom of the ladder, the x coordinate is increasing. The rate it's changing at, it's a positive velocity to the right. So if it's a positive velocity this way, this has to be a negative velocity going down. What that means is that it's a velocity going downward, and that would make sense that it's a negative number. Okay, so you'll see questions like this a lot with related rates that deal with the Pythagorean theorem. Make sure that you do have all the information. This is usually going to require you to find one little piece of information using some other method so that you can find the rate that you're trying to find.